Welcome back. Now that we know on a high level what is Spring Framework and what is Spring Boot, let's try to understand what do you mean by RESTful web services and how Spring Boot helps us to build RESTful web services. So if we see this is a server which can be hosting any application like with Java, Servlet or Spring, and this is internet. There can be many clients like laptop, mobile and a television. They can call to this server and talk to this server by the help of JSON request. JSON is the format in which the data will be exchanged between the client and server. It stands for JavaScript Object Notation. So we are building once the server API in a format which the clients can understand and any kind of clients can understand through the help of internet. So what is a web service? A web service is a collection of open protocols and standards used for exchanging data between applications or systems. So software applications can be written in various programming languages and run on various platforms over the computer network like internet in a manner similar to inter-process communication. So there can be program written on any technology here, and this can be client built on any technology, but they can interact with each other with the help of this RESTful web services and certain protocols. So REST stands for representational state transfer. REST means representational state transfer, which means REST uses various representation to represent a resource, where text, JSON, XML, these are the different formats of resource. So when a client tries to talk to this server, there can be different formats of data exchange in a text format, in a PDF format, in a JSON format, in an XML format. So web services based REST architecture are known as RESTful web services. So those architecture which are based on RESTful, those architecture which are based on REST architecture, those types of web services are called RESTful web services. So what are RESTful web services? Web services based on REST architecture. And what is REST architecture? There will be interaction between client and server over internet with through the help of either XML or JSON format. So now RESTful web services usually have a URL. So every URL is mapped to a resource at the server. So there can be multiple URLs. Each URL is mapped to a particular resource on the server, which means a function. So REST is a web standard based architecture and uses HTTP protocol for data communication. So REST actually is based on HTTP protocol, which means over the internet it can exchange data between client and server. So REST revolves around the resource where every component is a resource and a resource is accessed by a common interface using HTTP standard methods. And REST was introduced first by Roy Fielding in 2000, year 2000. So what it says is REST REST full web services are dependent upon HTTP protocol and the different methods of HTTP protocol that we are going to see now. And this REST was concept was first introduced by Roy Fielding in 2000. So these are the different methods of HTTP protocol which REST-based architecture uses or RESTful web service uses. So using this HTTP protocol and one of these methods, the client is able to talk to the server over internet, and the data form that is getting exchanged is either XML or JSON. So get provides read-only access. So if you have to read something from the server, the client should use get request of HTTP protocol. Get method of HTTP protocol. Put, it is used to update an existing resources on the server. Delete is used to remove a resource from the server. Post is used to create new resource on the server. Patch is used for partially updating a resource on the server. It's same patch is same as put, but it is used for partial update. Options is used to get supported operation on a resource. So let's say there is a resource. What are the different kinds of action that can be taken on that resource on the server? We can come to know with the help of options method of HTTP protocol. So here's our client. It is can do a post, put, get, delete, patch operation via HTTP protocol to our server, and based upon the type of method, our server will do some other calls to other backend system or maybe interact with the database server, and then it can respond back with another response here. So HTTP request has five major parts. One is the verb, which is the HTTP method get, post, put, delete. URI, which is the URL of the resource. HTTP version, which is the which version of HTTP we are using, and then request header, which contains different metadata information like in the key value pairs. So in future we are going to look at how a particular REST call looks like, and at that time we will see these are the different fields or values we will be able to locate. URI stands for Uniform Resource Identifier. So a URI is formed of protocol, which is HTTP, then the service name, resource type, and resource ID. So these are some of the example of RESTful web services or APIs or endpoints. Post, get, put, delete, delete, and this is also another example. So we are going to look at all this in detail in our upcoming lectures. So as per REST architecture, RESTful web services should be kept as clean as a client state on server. Should not keep the client state on the server. What it means is when we are building RESTful web services, one request should not be aware of what did the other request did. That's why RESTful web services are also called as stateless. Stateless means one request from one client to the server was not being known by any other request that will come in future or came in the past. So the RESTful web services are stateless. It is the responsibility of the client to pass the context to the server, and the server can store this information to process client's request further in future. So if they want to maintain the state, so now the client will make sure it will find a way that the server should recognize that it is the same client which was sending the request in the past. Otherwise, by default, the server will not understand any new request coming from the same client. It will treat the request as a completely new request coming from separate client. So idempotent operation means there will be always the same result no matter how many times these operations are invoked. So put and delete operations are idempotent, which means if you try to update a resource, let's say, then if you try to update it as many times as you want, it will get to give you the same result. If you try to delete an operation, delete something from the server, you try to do as many times as deletion, it will return you the same result. That's why update and delete are idempotent operations. As mentioned, HTTP protocol has some methods that we covered: get, post, put, delete, patch. HTTP also protocol also has some status codes which it returns. So if we return 200, it means it's okay, success, everything is fine. 201, something got created on the server, like in the example of post and put. 204 means no content was found. So let's say a resource was deleted on the server, then we can return 204 in case of delete operation. We can return 201 in case of post or put. 304 is resource was not modified on the server. 400 means it's a bad request, which means server is not able to understand the request that is coming from the client. 401 is means forbidden, that this particular resource is not allowed to be accessed by somebody else. 404 means the resource was not found on the server. The resource that was looked for was not available on the server. Next, we have some Spring Boot annotations. So these are the important annotations. One is enable auto configuration. What it means is, let's say there are 10 functionalities that we want to offer, but the 10 functionalities has to be enabled, right? But then how it works is, if we have enable auto configuration on our main class in Spring Boot, then if we just add the Maven dependency of a particular functionality, this enable auto configuration will make sure the functionality will kick in. Let's say if we put the Spring security related Maven dependency in our POM XML in the class path, then this auto configuration is automatically going to invoke the functionality related to Spring security because it found the dependency in the class path. Then we have at the rate Spring Boot application. This annotation is a combination of three annotation at the rate enable auto configuration, component scan, and configuration. Auto configuration enables the automatic configuration or enabling of the functionality of the component it finds in the class path. Component scan, it scans for all the packages for the different Spring Beans. Configuration, to make any class as a bean class, we can declare it as a configuration. Component helps us to declare any class as a singleton bean. Controller helps us declare any class as a Spring controller. Service is used to create another singleton class. Remember, controller, component, all these are creating singleton class. Same way, service and repository also create singleton class, but service is mostly used for business layer, and repository is used for the database access layer. Request mapping helps us to map a particular URL to a function. As we mentioned, in RESTful web services, everything is a resource which is mapped by a URL, which means this particular URL is mapped to a Java class function. This is mapped to another in the same class another function. This is mapped to another same class another function. So if we see in that sense, if every URL is mapped to a function, then there are certain annotation which helps to do this mapping. Request mapping is one of the annotation that helps us to map the URL to a particular class and its function. Request mapping is one of the generic way to map it, but if we want to go with a specific method type mapping, then we have get mapping, which is used to map the get request. Post mapping maps the post request of the HTTP URL to a method. Put mapping for update, delete mapping for deleting, patch mapping for partial update, and request body. This is used to convert the JSON format of the data that is coming. So at the start we saw this JSON format of the data that will come from client should be converted into the Java objects, and this is done with the help of @request body annotation. Similarly, path variable. Let's say in the URL we want to get this information. So if the URL, if this URL is containing something with after slash, let's say 1, 2, 3 number, if I want to get its value in my function, then I will have to use the annotation as path variable. Similarly, here this is not after slash but question mark title equal to something. So let's say I want to access the value of the title in my function. Then I have to use not path variable but request param annotation. So we are going to look at all this annotation, how they work with hands-on example. So this is request param. Similarly, if we want to access the header which is coming in the request, we can give @request header. And if we put any class with an annotation @rest controller, then it is a combination of a controller and response body annotation. So this response body helps us to convert the Java class into the corresponding JSON object, and it is itself annotated with address response response entity annotation. So response body annotation and controller annotation is equal to REST controller. So we are going to look at all this with examples. If the REST controller is used, then there is no need for annotating each method with REST response body. So this is an example how we can declare a simple class it as a REST controller class and give a request mapping on the class level, but get mapping on the method level, and we can get the request param which will give us this value. And in the request param we can also say whether it's a required field or not. And if you want to get the path variable value like this, then you can do something like this. We are going to look at all this with examples. One thing to notice, let's say if we want to access this controller endpoint from some other IP address and port like some other client, then we have to on the controller level make sure to give cross origin. The reason we have to do this is because our server and client are running on different IP addresses, and by default any browser for the security purpose blocks that if you are not running on the same server or same IP, the request will get blocked. Hence, By saying cross origin on our controller, we are saying to our controller allow request from any IP address. So this is an example, but we are going to look at nice examples in our upcoming hands-on lectures. So thank you for watching this video. I will see you in the next one.